Okay, welcome to our math class. I'm Micki Josi, your math teacher, and today we're going to talk about how we take a linear equation that has fractions in it and we actually clear the fractions. So we call this method clearing fractions. Remember that you can do whatever you want to an equation so long as you do the same thing to both sides. Okay. Now, this idea of clearing fractions requires us to find the lowest common denominator between all of the fractions. So as if I was going to add or subtract the fractions, I need to figure out how can I make them all have the same denominator? What would be the lowest common denominator between 9, 3, and 6? And there's a couple of ways you could figure this out. It has to be a number that they all divide into evenly. Okay, one way to figure this out would be like to take 9, factor it, 3 times 3. Okay, take 3. Well, 3 is already prime, so that's just 3 times 1. And then take 6, factor it. This is a factor tree, and make it 2 times 3. That's what we call prime factorization. Why prime? Because all of these factors then are prime. Okay, we don't really need the 1. The one that they all have in common, their GCF, their greatest common factor, is 3. Okay, so they have 1 3 in common. The 9 has an extra 3. So I need that extra 3. And then the 6 has an extra 2. So I need that extra 2. When I multiply 3 times 3 times 2, I get, anyone? 18. 18, excellent. So 18 is the lowest common denominator, okay? So now what I'm going to go and I'm going to do is I'm going to take each one of these fractions and I'm going to make them have the denominator 18. So I have to think about, okay, what I'm multiplying by one whole. I'm multiplying the same thing in the numerator and the denominator. What do I have to multiply 9 by in order to get 18? 2, right? So I'm going to multiply by 2 over 2, since that's going to be the same thing as multiplying by 1, right? Yeah. So I get an equivalent fraction. My equivalent fraction is 4x over 18. Do you see it? Okay, now I go to the next fraction and I say, well, what do I need to multiply this fraction by in order so that it will also have a denominator of 18? I want them all to share the same common denominator. So think about what number times 3 gives you 18. 6, yeah, and you can actually see it in the actually, sorry, this part was the GCF. The whole thing is the lowest common denominator, or LCM, the whole thing together. So you can see it in the lowest common denominator. I'm multiplying the GCF of 3 only one time since they all have that in common, and then I'm multiplying the extra 2 and 3. So the 2 and the 3 is 6. So I'm going to multiply by 6 over 6 so that I'm multiplying by 1, meaning I'm not changing the value. And what's the equivalent fraction to 2/3? Shouldn't that be 12/18? Yeah. And now over here, I want to do the same thing with 2x over 6. What can I multiply 6 by in order to give me a denominator, the LCD of 18? 6 times 3. So I have to do the same thing in the numerator and the denominator. So instead of writing x3, because that's awkward, I'm going to write that as 3x. Is that okay to write it as 3x? Do we get that? Yeah. So I don't want it to look like it's an exponent. Okay, now we have the idea that all of the denominators are the same. Okay, so the way we're wiping out the denominator, the way we're clearing it is we're actually saying, well, if everything is being divided by 18, then I can multiply both sides by 18. As long as I do the same thing to both sides, the 18 divides by the 18, that's like a cross cancel, right? So, or sometimes people will just take the denominators and just cross the whole thing out and say, okay, I'm going to now solve 4x plus 12 equals 3x. Any questions coming up so far? Do you like this equation better than the original one we started with? Looks easier to solve, yeah? Because there's no fractions in it. So that's the idea. We just cleared the fractions. What should I do to solve this equation now? Probably it'd be easiest if I subtract 4x from both sides, right? I get 12 equals negative x. I want to get x by itself. It's not quite by itself yet. So to get x by itself, I can divide both sides by -1. I should get x equals -12. Now, if that is correct, it will check. Okay, so this is the idea of the check. I have a friend, she puts it in a T-chart. I kind of like this method as well. You can go 2 times -12 over 9 plus 2/3. Does this equal -12 over 6? Let's find out if it does. Okay. So I'm just plugging in -12 anywhere I see an x in the original equation. So now I get -24 over 9. And if I want to add that, I should probably make an equivalent fraction here. So I'm going to make the 2/3 into 6/9. Is that okay? 6/9. Do you see how I did that? Does everybody understand why I would want, instead of 18, I can go just to 9 because I just need to add those two fractions. What's 24/9 plus 6/9? -24. -24/9. You owe 24, you have 6. Isn't that -18/9? Now simplify these fractions. What does -18 over 9 equal to? 9 goes into -18. Yes, -2. Over here, -12 divided by -6 is also -2. That means our answer is -12. Now, sometimes in your advanced math classes, when you're solving and you get a solution, you can put that solution in these set braces, and that's called set notation. Okay. Any other questions about that? So the idea here is to get a common denominator to make all the fractions equivalent so that you can clear out the fractions and just solve the equation that's left in the numerator. Okay.